Hello everyone, welcome to IB Army, and this is Jenny again. Today we're going to talk about the differentiation of exponential and logarithmic functions. So on the IB formula booklet, we are given that exponential functions such as e to the power of x, the derivative of that will be e to the power of x, which is the same. And then if it's ln x, which is a logarithmic function, the derivative of that function will be 1 over x. And then, as usual, we jump into the questions. So here's the first question for you guys. Differentiate y equals to x times e to the power of minus x squared. Oh, it looks really difficult. But again, thinking step by step, use and combine different rules and apply them, and you'll figure it out. Pause the video and try to do it. Okay, so we have the function x times e to the negative x squared, and as I've already said, if there's no plus or minus and there are two x in one term, this is a product. So you use the product rule, so you identify two functions and differentiate each of them, and you substitute them back into the product rule, and you figure out the answer. However, the tricky part is e to the negative x squared, the differentiation of that function. And again, you just use the chain rule where you see, okay, so the first part, negative x squared as a function, and then after differentiate e to the power of that you differentiate negative x squared again, and using the power rule. So it's quite straightforward. And the second question, find f prime x when fx equals to ln 1 plus x squared. Again, think about it and try to figure it out by your own. So in this case, you have the function ln 1 plus x squared, and we all know from the formula that ln something is a logarithmic function, and the derivative of that function will be 1 over that function. So we have that, but again, you have to apply the chain rule here. So you differentiate x squared after you differentiate ln 1 plus x squared, and the answer is 2x over 1 plus x squared. Be aware that you don't use something like quotient rule or something else in this case. You have to identify that there's ln, so you have to use the derivative of logarithmic function. Next question, differentiate ln x to the power 4. Again, use the formula and try to figure it out. So in this case, again, you have to use the chain rule because it's not just ln x, but ln x to the power 4. So you imagine x to the power 4 as a unit. You differentiate ln u, for example, and then you differentiate x to the power 4 and use the chain rule. You multiply them together, so you get 4 over x. Yes, so you can use that way, or you can just use some rules of logarithmic function. As you know that ln x to the power of a, that a you can take it as a constant and move it to the beginning, so it will become 4 ln x, and in this case you just use the constant rule where you just differentiate ln x and forget about the power and everything. Is more straightforward. So here you can see that in calculus you are using all the things you've learned in algebra previously, and there are so many different ways to solve one question. There's no right or wrong. I mean, the answer does, but the method, of course, there's not.